Space is vast and full of wonders. There are stars, planets, and galaxies of all shapes and sizes. But there are also places in space that are dark, mysterious, and even a little scary. These are black holes. Black holes are regions of space-time where gravity is incredibly strong. Imagine the Earth squeezed into a tiny marble. That's how dense a black hole is. Anything that gets too close, even light, gets trapped forever. That's why we call them black holes. No light can escape to reach our eyes. Black holes are not empty spaces. They are filled with a lot of matter packed into a small area. This makes their gravity very powerful. Think of a bowling ball on a trampoline. It makes a big dent. Black holes do the same thing to space-time. Despite their mysterious nature, black holes are important. They play a role in how galaxies form and evolve. By studying them, we can learn more about the universe and the laws of physics that govern it. Stars are like giant nuclear reactors. They burn fuel in their cores and produce light and heat. But even stars don't live forever. When a massive star runs out of fuel, it can collapse under its own gravity. This collapse is what creates a black hole. Imagine a star much bigger than our sun. As it runs out of fuel, it can no longer hold itself up. The core collapses inward, squeezing the matter into a smaller and smaller space. The outer layers of the star explode outward in a supernova, a spectacular cosmic event. If the core of the star is massive enough, the collapse doesn't stop. It keeps getting smaller and denser until it forms a point of infinite density called a singularity. This singularity is at the center of the black hole. Around the singularity is a region called the event horizon. Once something crosses the event horizon, it can never escape the black hole's gravity. Black holes come in different sizes. Some are small, while others are incredibly massive. Astronomers classify black holes into three main types: stellar mass black holes, supermassive black holes, and intermediate mass black holes. Stellar mass black holes are the most common type. They form when a single star collapses. These black holes are typically a few times more massive than our sun. Supermassive black holes, on the other hand, are millions or even billions of times more massive than our sun. They are found at the centers of galaxies, including our own Milky Way. Astronomers believe that intermediate mass black holes exist, but they are much harder to find. These black holes are thought to be hundreds or thousands of times more massive than our sun. They may form from the merger of smaller black holes or the collapse of giant gas clouds. Section 4. Warping reality: black holes and spacetime. Black holes are not just massive objects, they also have a profound effect on the fabric of spacetime itself. Albert Einstein's theory of general relativity tells us that gravity is not a force, but rather a curvature of spacetime caused by massive objects. Imagine a bowling ball on a trampoline. The ball causes the trampoline to sag, creating a dip. Objects placed on the trampoline will roll towards the bowling ball because of the curvature. Black holes do the same thing to spacetime, but on a much grander scale. The intense gravity of a black hole warps spacetime so much that it creates a deep gravitational well. Anything that gets too close to the well, even light, gets trapped. This warping of spacetime also affects time itself. Time slows down near a black hole compared to a distant observer. Section 5. Unmasking the invisible. Seeking the cosmic abyss. Black holes are invisible to telescopes that detect visible light. However, astronomers can still detect them by observing their effects on nearby matter and light. One way is to look for stars that are orbiting an invisible object. If the stars are moving very fast, it could indicate the presence of a black hole. Another way to detect black holes is to look for the effects of their gravity on light. As light passes by a massive object, its path gets bent. This is called gravitational lensing. Black holes are so massive that they can bend light from distant objects, making them appear brighter or distorted. In recent years, astronomers have made significant progress in observing black holes directly. The Event Horizon Telescope, a network of telescopes around the world, captured the first ever image of a black hole in 2019. This groundbreaking image provided direct evidence of the existence of black holes and their event horizons. Black holes remain one of the most mysterious and captivating objects in the universe. They challenge our understanding of gravity, space-time, and the nature of reality itself. As we continue to study these cosmic enigmas, we can expect to make even more exciting discoveries in the years to come. So, keep looking up at the stars, and who knows what other mysteries the universe holds.